পাসওয়ার্ডটা দেখো এই যে পাসওয়ার্ড যদি চাই, এই যে পাসওয়ার্ড, মিটিং নাম্বার আর পাসওয়ার্ড, বুঝতে পেরেছো?
এগুলো তো খুলবে না, লক হয়ে যাবে।
এই যে এখানে গেলে হলো, এখানে গেলে হলো, এই তো তিনটা আসা।
হ্যাঁ। সরকারি কাজ হচ্ছে।
क्या हमसे आप क्या सीखना है? क्या दे दीजिए, ये तो आप नहीं बोल सकते तो।
Good morning, sir. Good morning, sir. Mana mata. Horror ko mana. Abang lambat pita lah. Ay por. Dara, change of audio connector. Change of audio.
Good afternoon, everyone. We will just start in 5 more minutes. Okay, we are just waiting for more participants to join. So just bear with us for another 5 minutes, and in another 5 minutes, we'll be starting the proceedings.
Shailesh sir,
Yes. Yeah. Yes, Manish.
JS sir has also joined.
Okay.
So
Okay.
we'll just start. Huh?
Okay. So shall I start now? Okay. So shall we start now? Okay. Good afternoon, everyone present in this webinar series. Okay. Good to go, Manish?
Yes, sir. Good to go.
Okay. So good afternoon, everyone. Present in this webinar series at Lighthouse Project Sites. My name is Shailesh Agrawal, and I, on behalf of Ministry of Housing and Urban Affairs, Government of India, and BMTPC, GIZ, and on my personal behalf, extend a heartfelt greetings and welcome you all in this fifth webinar on Lighthouse Project, which is being held at Chennai Lighthouse Project Site. I also thank and welcome Shri Kuldeep Narayanji, Mission Director and Joint Secretary, Housing for All, Ministry of Housing and Urban Affairs, Government of India, for his benign presence and constant motivation for wider advocacy and dissemination of innovative construction systems being used in these lighthouse projects through constant dialogue, training, on-site visits by multi-stakeholders. I also greet other officials from the ministry, PMU team and GIZ team. Tamil Nadu Slum Clearance Board, which is the state level nodal agency, their MD, engineers, and officers deserve a special applaud here for their proactive support for timely completion of the Chennai Lighthouse project, and I welcome all of them in this webinar. My warm greetings also to SLTC, CLTC team, including officers, engineers, and architects of other Tamil Nadu state level agencies. The representatives of technology provider and the construction agency, which is Messrs. VG Shirke Private Limited, one of the pioneers in bringing precast concrete construction in India, are also welcome to this webinar. Congratulations to the entire project team deployed at Chennai site for finishing the project expeditiously. I am sure the state government will certainly replicate this versatile precast concrete construction system in their future endeavors. Today's webinar is being held at Chennai, which is one of the lighthouse project site under Global Housing Technology Challenge India. And first, we will give you a brief exposure to the latest innovative construction systems shortlisted through GHTC India and being promoted within the country, followed by a specific technical presentation on the Chennai project. To apprise our Joint Secretary, sir, the participants in this webinar are not only TECHNOGRAHIS, who registered through online enrollment drive initiated by our ministry, but also we have engineers, architects, planners, professionals, faculty members, teachers, developers, technology providers, and students from engineering and architecture colleges of not only Tamil Nadu state, but also from other parts of the country. These lighthouse projects, let me share with all of you, provide us a unique opportunity to learn the field level application of innovative construction system in real time and build capacities within our country for its further adaptation and replication, so as to build new young India, which is Atmanirbhar. The use of these innovative construction systems is more pertinent in today's context, as globally we are committed to bring resource efficiency, energy efficiency, eco-friendliness, and disaster resilience to steer our country towards sustainable and inclusive development. Also, to take India to $5 trillion economy, we need to deliver our buildings and infrastructure pretty fast. And let me tell you, all these innovative construction systems, which we are going to deliberate through these webinars, impart not only speed to the construction activity, but also help deliver superior affordable housing and infrastructure, which is better in terms of structural and functional performance, quality, durability, than the business as usual approach, which is conventional RCC framed and brick construction. Just to give you a brief overview, at present, these innovative construction systems are being implemented in 6 lighthouse projects in 6 places, namely Rajkot, Chennai, Indore, Lucknow, Ranchi, and Agartala. At all these 6 lighthouse projects, 6 distinct innovative technologies are being used, and we will be holding webinars at all these 6 places to make you understand about these the nuances of these systems. So far, 4 webinars have already been organized at Rajkot, Indore, Lucknow, and Ranchi. There will be 40 webinars till 2022. During the webinar, we will also be taking you to a virtual tour of LHP site so as to take the stock of present construction activities and give you hands-on experience on the construction technologies and processes being used in the project. I sincerely hope all of you will get greatly benefited by this webinar and learn new methods of construction, which will help you in your future projects and endeavors. Before I get into the technical details, it's my pleasant duty to invite our Joint Secretary, sir, who has been leading the mission from the front and a constant source of encouragement to make his opening remarks. Over to you, Kuldeep, sir.
Thank you, Shailesh. Let me welcome everyone in this, what I call 5th session of the seminar. Is that right?
Yes, sir. Yes, sir.
This is 5th learning webinar, where we are concentrating on learning from our lighthouse projects, and even at cost of repetition, let me emphasize the importance of these lighthouse projects, how these have been conceptualized for propagation of new technologies which are resource efficient and fast paced. Purpose of construction has been that let government demonstrate these technologies by constructing houses under EWS category for affordable housing, and show how these houses can be constructed within a period of 1 year or so, as compared to the traditional technologies which take almost 2 years. I welcome all the members of academia state government, students, all practitioners who have joined us today. You are all welcome to visit the site also. Today we'll be seeing the videos from the site, and also BMTPC will be giving technical sessions on how this technology is executed. You should see, and then if you want to, you should visit the place also. There is nothing like seeing is the believing. So I welcome you all, and this Chennai, I must congratulate the project team that Chennai has been probably the first one which is getting completed within a year or so. We are planning to give the final possession to beneficiaries in month of April and May, and occupancy is expected in next few days. So the way it has been constructed, it actually shows how any time saved is money saved. Time is money. If you construct your building 1 year in advance, 6 months in advance, you are actually saving money on rental, you are saving money on project expenditure, you are saving money on building materials also. So any of you who have not yet enrolled as Technograhi, I would request you enroll as Technograhi, learn about these technologies, not only LHP Chennai, but other five lighthouse projects also. And the students who are doing their engineering or architecture, you may also think about doing some thesis on these technologies. That would be good for your career and future learning. So I welcome you all. Let's be proactive in learning these technologies and propagating it. Thank you so much.
Thank you, Kuldeep sir. Now we will run a short film of 5 minutes for the LHP at Chennai. May I request Manish to run the film?
Ministry of Housing and Urban Affairs, Government of India, has initiated Global Housing Technology Challenge India. Technologies as to bring paradigm shift in the construction sector. 54 innovative technologies put in 6 broad categories were shortlisted during the challenge process. 6 lighthouse projects at 6 locations with 6 distinct technologies are being constructed. Lighthouse project using precast concrete construction system, components assembled at site with 1,152 dwelling units in G+5 configuration, along with all basic and social infrastructure facilities, is being constructed at Chennai in partnership with the state government of Tamil Nadu. The Honorable Prime Minister laid the foundation stones of 6 lighthouse projects, including at Chennai, on the 1st of January 2021.
आज गरीबों के लिए, मध्यम वर्ग के लिए, घर बनाने के लिए नई टेक्नोलॉजी देश को मिल रही है। ये 6 लाइट हाउस प्रोजेक्ट देश में हाउसिंग कंस्ट्रक्शन को नई दिशा दिखाएंगे। चेन्नई में अमेरिका और फिनलैंड की प्री कास्ट कंक्रीट सिस्टम का उपयोग करेंगे, जिससे घर तेजी से भी बनेगा और सस्ता भी होगा।
The construction process comprises of manufacturing of precast concrete columns, beams and slabs in MS molds. The reinforcement cages are placed at the required position in the molds. Concrete is poured and compaction of concrete is done by shutter, by needle vibrator. Cast components are then moved to stacking yard, where curing is done for required time. The final components are transported to site, erected and installed by crane, and assembled together through in situ jointing and or grouting, etc.
Construction of LHP Chennai was started with excavation of site, followed by laying of plain cement concrete, footing work, erection of stem column as per foundation design, placement of plinth beam and backfilling to complete the substructure. After this, superstructure work started sequentially, involving assembly of precast columns, beams, slabs, and stairs. As the superstructure progressed in different blocks, masonry work and fixing of electrical and plumbing services, fixing of window frames started in a planned manner. Superstructure work of all the 12 towers, which were taken up in a pre-planned schedule, are now complete. The internal and external plasters and painting have also been completed in all towers. Simultaneously, infrastructure work of drainage, sewerage, water tank, erection of compound walls, etc. are in progress. Work on amenities buildings, Anganwadi, ration shop, milk booth and library, etc. are also going on in full swing. A sample flat with all the amenities has been ready in Tower 11 for showcasing it to the beneficiaries and other stakeholders. With completion of about 92% overall work, the project is likely to be completed by the end of March 2022 and should be ready for occupation by the beneficiaries by April 2022. The LHP Chennai is serving as a live laboratory for learning. About 200 TECHNOGRAHIS and other stakeholders have visited the site to learn the use of innovative technology in a real project at site.
Thank you. Thank you, Manish. Okay, now we will make technical presentations. So first, I will take you through the 54 innovative construction systems which were shortlisted through Organization of Global Housing Technology Challenge. So I'll be making a quick presentation on the technologies and their category and try to explain you, pictorially those technologies. And after that, we will have a complete session on Chennai project, the technology being used and how it is being implemented. You can also visit Ministry's website, GSTC website or BMTPC website to download various publications, various presentations, and we have also developed audiovisual capsules on all these lighthouse projects and their related technologies. So in case you miss out something, you can always download these things from either of these websites, or we also have a YouTube channel with the name BMTPC. From there also you can download the presentations and other relevant literature. So let me just share my screen with all of you, and I hope it is visible. Okay. Okay.
Yes.
It's visible. Okay. So let me again.
It's okay.
Yeah. So this is webinar number 5, which is being done at project site Chennai. And first we will take you through the emerging construction systems which have been shortlisted by Ministry and being promoted across India. Before that, let me tell you that the entire technology propagation, technology promotion, Global Housing Technology Challenge is being done under the ambit of Pradhan Mantri Awas Yojana, and we are running a technology submission under Pradhan Mantri Awas Yojana through which we facilitate use of green, clean technologies, emerging construction system, quality, quality and affordable housing. So it's let me just give you overall progress being done in Pradhan Mantri Awas Yojana. We have already achieved the validated demand, which was 1.12 crore houses, and already 1.22 crore houses have been sanctioned, out of which 97 lakh have been grounded and more than 56 lakh have already been completed. And this figure is very fast changing. And the good news is, out of these sanctioned houses, out of these grounded houses, 16 lakh houses are being done with these new technologies which we are going to talk to you. And there are 4 verticals, all of you know: beneficiary-led construction, affordable housing, public-private partnership, then in situ slum rehabilitation, and CLSS. In addition to these statistics, PMU, Pradhan Mantri Awas Yojana Urban, has been quite successful in generating direct and indirect employment. So far, 3 crore jobs have been, generated through Pradhan Mantri Awas Yojana. And also, we try to estimate the overall consumption of cement, steel, and you will find in the graphs which are given below that it is expected the projected overall consumption of cement is 73 million ton, whereas steel stands at 16.6 million ton. So with this, let me start the presentation on Global Housing Technology Challenge. Most of you might be knowing, but just for the sake of repetition, let me tell you this Global Housing Technology Challenge was the milestone, or rather I would say it is a milestone in bringing technology transition in the construction sector. And it was conceptualized by Ministry of Housing and Urban Affairs and organized on 2nd and 3rd March 2019. Honorable Prime Minister inaugurated this Global Housing Technology Challenge, and during the challenge, we organized expo cum exhibition where more than 70 companies, national, international companies participated and showcased their construction system. And the word challenge may bother you. Challenge thrown to the the challenge which was thrown to the global technology provider. Do we have construction systems or technologies which can help build maximum number of houses in minimum time and minimum cost? So maximum houses, minimum time and minimum cost was the challenge. And through this challenge and through that exposition, we could shortlist 54 new construction systems which are shortlisted here. And we have, categorized them into these 6 categories. And this entire exercise was done under Technical Evaluation Committee, which was chaired by DG CPWD along with members from academia, research organization, and public sector undertaking. So these 6 categories, right now we are showcasing these 6 categories at 6 lighthouse projects, which and at each 6 lighthouse projects, not only webinars are being conducted, but we are also taking physical visits, and you all can go and see yourself the implementation of these technologies. So now I'll try to explain you quickly what are these technologies. The inauguration foundation stone laying was done by Honorable Prime Minister on the 1st January 2021, and as I will be sharing with you this Chennai project. The Chennai project is almost complete, and as Jay sir was telling all of you that maybe in a month we will be handing over the houses to the beneficiaries. So that is the kind of speed. If we want to fast track construction, these technologies are the answer. And while inaugurating these lighthouse projects, Honorable Prime Minister emphasized that let's treat these lighthouse projects as live laboratories, and let's make use of this opportunity to learn about the technology, make these technologies as our technologies, and make these technologies as future technologies, and try to implement them across India in our future the projects of buildings and infrastructure. Before I get into innovative construction system, let me just quickly tell you what we have in our hand. So all of you know about this, that majority of construction world over is by these 2 methods which are shown in the pictures here. The picture in the upper half is load bearing construction, where you create the walls brick by brick or stone by stone, and then over that you lay up the RCC cast in situ RCC slab. So that is the load bearing construction, and nowadays this construction is also being replaced by the RCC frame construction, which is shown in the picture on the right hand side, bottommost. So here what we do, we create a structural system through cast in situ RCC beams and columns, and then the spaces in between beam and columns are filled with the infill walls, and the slab is cast in situ. And you all will agree, I have a slide to show you that these are slow track construction, time consuming, waste generating, disaster resilience is not that much which is required, quality, durability, whole lot of issues are there, labor dependent and things like that. So there is need, and also this is also called a business as usual approach. So these need to be replaced by some new innovative construction system, and that is why this exercise of GSTC was conducted, and through this GSTC the technologies which are shortlisted being promoted across India for construction purposes. So this is just to give you the comparison. So conventional construction systems are the systems which I showed you in this slide. So these are the conventional construction systems, and innovative construction systems are, or alternate construction systems are the system which I will show you in my further slides. So conventional construction system is slow track, whereas this is fast track. The maximum use of natural resources in conventional construction system, whether we talk about cement, sand, soil, stone, where in alternate construction system you are optimizing. We don't say that don't cement, sand, optimize the use of resources. In fact, we have technologies where use of water is bare minimum, and all of you know water is scarce. Water is a precious commodity. So through these employing these the innovative construction system, you can optimally use these resources which we have. Waste generation is minimized when you use alternate system. Pollution, when we talk about, all of you know, dust pollution, air pollution, greenhouse gas emission, and water pollution with this conventional construction system. There are huge construction and demolition wastage generated when we do construction conventionally or using business as usual. Whereas in innovative construction system, this all can be minimized. Conventional construction system is labor intensive, dependent on weather also, and all of us witnessed it during the pandemic that most of the construction projects came to halt or came to standstill during COVID time, because the labor workforce started migrating and there was no work at the project site. Whereas these systems are industrialized system where majority of the construction or majority of the work takes place in the factory. So that way you can bring in mechanization and automation in the construction. Prescriptive design, most of the conventional systems are based on prescriptive design, like you go to a doctor and he writes some medicines to you, and you, without asking anything, you keep taking them. Similarly, in conventional construction system, we have pre-decided sizes, 9-inch wall, that should be the height, and these are prescriptive design, thereby sometimes making the design not economical. Whereas in alternate construction system, because they are customized, tailor-made, and thicknesses and all, everything is being optimized. So construction systems, innovative construction systems offer cost-effective economical design. Unhealthy indoor air quality, whereas alternate systems offer better health and productivity. And if you have a better health, if the building is being occupied, if the occupants of the building or infrastructure are in good health, productivity increases. So, another very important thing is that just after construction, they require regular maintenance. Whereas in case of innovative construction system, because most of the things are done in the factory under highly controlled condition, the maintenance is to bare minimum, thereby reducing the low life cycle cost. And that is why nowadays we are propagating not the initial cost per square meter, but we should take into account life cycle cost, which is summation of initial cost plus maintenance cost plus the disposal cost. So all these alternate construction system offer minimum life cycle cost. Energy intensive, conventional construction system are energy intensive. You have to transport. There are a whole lot of energy being used for hoisting and other things, mixing and all. Whereas alternate construction systems make use of processes and technologies which are energy efficient and less dependent on energy intensive processes. When you do construction at cast in situ, and when it is dependent on supervisors and artisans and all, you all know the kind of structures we produce. Quality control and quality assurance is not as desired. Whereas in this system, when you do anything in the factory, quality control is quality control and quality assurance is being achieved. So the products or building components which you make in the factory are better as far as quality is concerned. Greenhouse gas emission, we all are talking about climate change, climate resilience, and eco-friendliness. So whether we talk about cement, steel, and all these things, they emit, during their manufacturing, they emit a lot of carbon dioxide, which is a greenhouse gas. So through these systems, if we optimally use these high GHG emitting materials, we can always reduce the overall greenhouse gas emissions. And all these points which I explained to you make alternate construction systems sustainable, which is the need of the hour, whereas conventional construction systems now have become unsustainable, and it is high time that we shift from conventional to alternate construction system. This is just an acronym which we have developed for you, that if we use innovative or emerging or alternate. So you can call them by any name: innovative, emerging, or alternate construction system. They help us to build safer structures. And this SAFER is acronym, and S stands for sustainability, which means resource efficiency, climate resilience, environmental friendliness. Then A means affordable because cost effective and fast construction. Faster delivery of houses and infrastructure will definitely save the cost. Functional, now and then functionality in terms of thermal comfort, in terms of sound, in terms of water leakages and tightness, fire retardance is being talked about. Let me assure all of you here that these emerging construction systems, as far as their functional performance is concerned, it is much superior than your conventional system. Overall, the structures which we build using these systems are economical because, as I explained you, they don't require regular maintenance, thereby reducing the life cycle cost. And quality is better, so these systems are durable. And India is a country where we have recurrent earthquakes, cyclones, and there are natural hazards as well as man-made hazards. So these systems offer resilience with respect to natural hazards and structurally superior. So always remember this: these innovative construction systems help you build safer structures. Also, in terms of sustainability, some of you must be architects here and policy and working with policy level interventions. And India is committed to reduce its carbon footprint, greenhouse gas emission, less dependence on energy efficiency. So let me share with you there has been a study by the Energy Research Institute, and by using these innovative materials, processes, and technology, you can significantly reduce the energy use, 30 to 40%. Water, which is very precious, 40% reduction in water. In fact, the technology being used in indoor, we are using the panels where we don't use water. So imagine the wall being constructed without use of water. Okay, 35% reduction in greenhouse gas emission, and you can reduce the waste being generated at the site can be reduced up to 75%. So now with this, the 6 categories, let me pictorially show you these 6 categories. Remember these 6 categories: 3D volumetric construction, 2D precast concrete construction, which we are using in Chennai. Then third category is light gauge or steel structural system. Then fourth is drywall construction, which is sandwich panel system. And fifth is monolithic or aluminum formwork systems. And sixth is stay in place formwork system. So first is 3D volumetric construction, and you can see from this picture that what we are doing is that business as usual. Remember the slide which I showed you, where I presented that most of the construction in India takes place is RCC, cast in situ RCC frame construction. So what about replacing that RCC frame construction, which is shown in the upper rightmost portion here, being replaced by this kind of system? And believe me, these 3D modules or these 3D pots or these 3D volumetric construction is done in the factory, and then you put these modules one over other, what you see in the bottommost picture, one over the other, to create the multi-story towers. And this technology is being used in Ranchi. The last webinar was conducted there, and virtually we shared, in fact, the pod element was erected at the site during the webinar. So you know the advantages, and you know what I was talking about. The moment you put blocks like this one over the other, you save on a lot of things and you achieve good quality. Speed is also achieved. So these are the different stages. What you do is you have a mold, then you put a reinforcement cage, then you pour the concrete, then demold it. Then what you get is that kind of the second picture which you see here. So you get this kind of module. Then that module is taken to the site, and on the already laid foundation, you put that block one over the other block and create this kind of multi-story stock. And through Global Housing Technology Challenge, we could shortlist 4 companies who are into this global 3D volumetric construction. And the one project which we are doing in Ranchi Lighthouse project is being done with this technology, which is given at number 3, and the company is Magic Creed Building Solutions. And all of you, if you want to get more details, you can go to the ministry's website or our website and get the films. We have created a film on Lighthouse project as well as specific films on the technologies, so you can get more insights about the technology by visiting these websites. And you can also visit through gstc-india.gov.in website. You can access the LHP site and see with your own eyes the live progress and the status of the project. Okay, now let's, so this is just the picture. And as I told you, you can see the live status by visiting that website, GSTC website. Here we are using this 3D volumetric construction in Ranchi, where 1,008 houses are being constructed in G+8 configuration. Let's move to the next category. In the first category, both these categories are precast concrete construction, but in first category, we are constructing the entire room, module, or pod, whatever you may call it. So it comprises of 4 walls and a floor. So you can have 4 walls and a slab, and that is why it is called 3D volumetric construction. And here we are using the instead of 3D volumetric construction, it is 2D planar elements. And what I mean by planar element means wall, beams, columns, panels, slabs, staircases. All these structural elements, you know, a building comprises of beam, column, slab, staircase. So all these are, cast in the factory or in the casting yard, and then you transport them to the site and assemble them at site to create the structure. And this is the technology which we are using in Chennai. So remember this slide. This is remember this picture which is on the topmost portion. This is cast in situ RCC frame construction. This is being replaced by customized factory made various structural polymer. Whether it is, I will show you next slide. Yeah, these are the various structural components. This is a hollow core panel. You can have solid slab panel. You can have staircase. You can have slender beam. You can have slabs. You can have wall panel. You can have facade. So all these, as per your project, these are being cast separately and then brought to the site and assembled at site. Through Global Housing Technology Challenge, 8 companies were shortlisted, and they, the project in Chennai is being done by a company called Lhp Construction Technology Private Limited, which is appearing at number 2 here. And in addition to this, there are a big number of companies who are into 3D, the precast concrete construction in the country. And this is the project Chennai, which I will be discussing with you in detail after this lecture. So next, let's move to the third category. Nowadays, use of steel in building and being promoted very aggressively, because if we want to, India is fast developing, and to take India to $5 trillion and $10 trillion economy, it is must that we enhance the use of steel. Per capita consumption of steel in our country is right now slightly low than the global average. So enhancing the use of steel in every sphere of life is the call of the day. So therefore, in building construction also, use of steel is being encouraged, and that is why you can replace this RCC frame construction or RCC structural system, which comprises of beams and columns, by this steel beam and column. These are hot rolled steel beams and columns. And nowadays, these hot rolled, the technology is such that instead of rolling the steel in I sections and other kinds of sections, you can have built up section, and you can create these built up sections. And with the manufacturing of built up sections, there is flexibility in steel design, and it can be used for residential purposes as well. And these built up sections offer you rectangular hollow sections and all, making building lighter in weight. And steel is now good and can be used for residential purposes and being promoted by us for residential. Earlier it was used for industrial and pre-engineered construction, pre-engineered building kind of thing, but now in building things it can also be used. And at present, the 3 projects which we are doing under Lighthouse projects are using a hybrid system, where structural system is comprising of this hot rolled steel frame with comprising of steel beams and steel columns. Namely at Lucknow, at Agartala and Indore, we are using this kind of system. This technology, in fact, all over India it is being used, and I just wanted to share with you this picture. After Hudud cyclone, the victims of Hudud cyclones were to be rehabilitated pretty fast. So Andhra Pradesh government used this technology, hot rolled steel sections for beam and column with AAC panels for rehabilitating the victims of Hudud cyclone. Now let's move to the next category, which is cold form steel. And there are 2 kinds of steel. One is hot rolled steel, and other is cold rolled steel. And cold rolled steel is also very popular nowadays, and it opens up enormous potential for constructing low-rise structures. In fact, during COVID time, several hospitals, in fact, even in our country, and isolation COVID centers were constructed using this light gauge steel structure system. Again, the basic premise which is shown in this picture, you can see the RCC frame is being replaced by LGSF wall panels and the frame. So this is cold form steel, and because it is cold rolled steel, so it is galvanized, and it offers a very thin and light jet and other kinds of C sections and jet sections, and these are made in the factory, and you just these panels can be lifted easily by 1 or 2 persons, and then you can just erect them, and you can put the fiber cement board or other kind of coverings to create the structure. Through Global Housing Technology Challenge, we could identify 16 technology providers who are into light gauge and steel structural system. And right now, Mitsubishi Housing Limited, they are doing the project in Agartala using this light gauge framing system, which is being used in hybrid form with steel structural system. This is that project in Agartala which is being used, and if you can see this, the picture in the bottom rightmost portion, you can see what I'm talking about. So this is a hybrid system. Now RCC beam and columns are replaced by these hot rolled steel RCC sections, and what is instead of having typical wall of masonry, we are having LGSF wall panels, which are shown here. This picture. Then let's move to the next category. Next category is drywall construction, and this is also known as prefabricated sandwich panel system. Let me just explain you what does the sandwich means, because sandwich means a core. If you can see in this picture on the right hand side, this is a core, which is a lighter core, which is sandwiched between two outer skins, and these outer skins can be cement concrete, it can be precast concrete panel, it can be fiber cement board, it can be calcium silicate board, it can be AAC panel. So the idea here is you have fiber cement board or any other outer skin, and the inner core is lighter in weight. And this core is normally, you all know about polyurethane foam. So what you see here, this is a PPGL which is used in industrial structure. So you have a pre-painted galvanized profile sheets, and in between you have puff. So similarly, you can have, if you want to use it as a wall panel, you can have what you see white thing here is EPS panel, expanded polystyrene. Then you have a welded wire mesh, and then you can do the concrete. I will show you in another picture. So there are a whole lot of sandwich panel systems available, and we are using this technology in Indore. I will show you the picture of that as well. So the basic premise here is that load-bearing walls can be replaced. These brick or masonry walls can be replaced by these customized walls, which are made in the factory with opening, without opening, with services or without services, as per the requirements. So just imagine replacing your wall, which is being constructed brick by brick by this tailor-made customized wall in the factory. This is that sandwich panel system. This is called EPS core panel system. So what you see, this white thing is expanded polystyrene. And if I have to explain you what is expanded polystyrene, expanded polystyrene is nothing but a thermocol of high density. Thermocol, the density of thermocol is around 5 kg per meter cube, whereas the density of this EPS is expanded polystyrene is 15 kg per meter cube minimum. So what you have this kind of panel, and this panel can be used in variety of ways. It can be used for load-bearing application, non-load-bearing application, double wall panel. It can be used as a slab panel, what you see here. It can be used as a staircase panel as well. And this is being light in weight, so it offers a lighter, and which is superior when we talk about earthquake resistance. And once you have this kind of welded wire mesh, which is galvanized, then you can do the concreting, you can do the shotcreting, or you can put a panel like this. So all these innovative systems offer you great amount of flexibility. Okay, so as per your finances, as per your requirement, you can have any kind of option. Okay, through Global Housing Technology Challenge under drywall construction, we could identify 9 such systems, 9 technologies, and right now in Indore we are using the technology of Rising Japan Infra in hybrid mode, where the structure system is steel and walls are made of this EPS cement sandwich panel. I have a slide. I will show you this panel as well. So remember, this is a sandwich panel. Sandwich panel means you have a lighter core which is sandwiched between outer skins, and those outer skins can be anything. It can be a cement panel, it can be fiber cement board, it can be calcium silicate board, or it can be simply plaster or shotcreting. This is the picture from Indore, where we are using this kind of EPS cement sandwich. Okay, so you can see here I have So you can see here, so this is the panel I was talking about. So what you see, you have a calcium silicate board as skin, and in between it is filled with lightweight concrete, which is again a special kind of concrete, also known as elevated concrete. The material used is cement, sand, fly ash, and EPS granular walls. So we don't use aggregate here. The coarse aggregates are replaced by this EPS, which is expanded polystyrene granular walls, okay, and cement, sand, and fly ash. So with this, you create the core, and then you sandwich that core in between two calcium silicate boards, and this is what is being used in Indore. Next is monolithic concrete construction, and some of you might be remembering this technology with the name Aluminium Formwork or a MI1 technology. So this is the technology which, let me tell you that this is the most widely, most widely used technology in our country. So this is the Aluminium Formwork, and what all of you know that if we construct a building or a house, normally, first we erect the formwork for columns, then we erect the prepare the formwork or a shuttering for the slab and beams, and then we de-shutter, and it's a complex and time-consuming process. How about instead of erecting formwork for each element separately, we create a formwork, or we fabricate the formwork for the entire module together. So what you see here, so instead of making beam, column, and wall separately, we created a customized formwork for the entire module, or for the entire room in the factory, brought it to the site, and on the already laid foundation and reinforcement cage, we put this formwork, pour the concrete in a single pour, and then next day you remove this formwork, take it to the next floor. So in 3 days, you can construct a dwelling unit. This technology, there are a number of variants of this technology. Through Global Housing Technology Challenge, we could identify 9 such technologies or technology providers. And right now we are using this in Rajkot, which is at number 8. And the technology uses tunnel form, and it is Ortinard Formworks Private Limited technology. And let me tell you, the first webinar was held in Rajkot, and in Rajkot, 8 dwelling units of 30 square meter carpet area are being cast in 3 days. So in 3 days, the entire floor, one floor is being cast using this tunnel formwork system. And why it is called monolithic? Because there are no joints here. So because you're not making beam, column, slab separately, you are, constructing or casting the entire room together. So everything is monolithic, and there are no joints. So thereby there is no maintenance, excellent for seismic resistance. So this is the Rajkot project I was talking about. And if you could see on this middle picture on the right hand side, this is that inverted L kind of formwork system, and it is of steel. So it creates a L. So what you have, you create the tunnels. So you create, instead of all the 4 walls, you create the tunnel kind of thing, and those outer walls, remaining walls, are filled later on with any infill material, whether AC blocks or any other stone masonry or any drywall construction. And this is a picture from that Rajkot project using this monolithic concrete construction. This is the technology being used in Rajkot. So what you see in this picture, what I showed you is the aluminum formwork for the entire room. The only variation here is this is an inverted L, okay? And when this is used, so this forms a tunnel kind of thing, okay? So you cast a slab and 2 walls together to create a tunnel, and the remaining walls are later on filled with the infill walls of stone or brick masonry, depending upon the requirement. Okay, so this is what we are using in Rajkot. Now let's move to the next category. Next and the last category is stay-in-place formwork system. So I've been talking about formwork system. So the earlier formwork system which I showed you, once the construction is done, then you remove that formwork. Okay, here this formwork stays with the structure. Okay, so in earlier slide which I showed you, formwork is stripped off. Okay, and here the formwork stays with the structure, to act as part of the structure, and that is why it is called stay-in-place formwork system. It is known with several names. So you can see here. So this is again that white thing I was talking about. This is the expanded polystyrene blocks. So instead of making a wall of brick by brick, you create these are customized blocks which are made in the factory, and they come in thicknesses of 100 mm to 200 mm. So you put them block by block to erect the wall. Then you can fill it with lightweight concrete, do the plaster. So first it acts as a formwork, and later it acts as an insulation. Okay, so you can see this. We are using this technology in one of the demonstration housing project in Bhopal. What you see here, these are expanded polystyrene, and this being expanded polystyrene is very excellent in offering thermal comfort. Okay, so this first acts as a formwork, and later it acts as an insulation layer. Okay, so through Global Housing Technologies, 8 companies were shortlisted, and the company appearing at row number 4 or serial number 4, that is Novel Assembler, that is a pre-finished wall form. Okay, I will show you in a slide. So this is the technology which we are using in Lucknow in hybrid mode with steel structural systems. So I think I have a slide. Yeah. So this is that slide which shows you the progress of Lucknow project, and you can see. So structural system is of steel, and this walling system is of stay-in-place formwork, which is a pre-finished PVC wall form system. I will show you this. Yeah. So imagine this is known as stay-in-place PVC wall form system. So these are pre-finished walls which you get from the factory. And what you see, the skins, again, the outer skins are of PVC, and you have cavities here, and these cavities can be filled with lightweight concrete or proper concrete, M10, and any grade of concrete or lightweight concrete with reinforcement or without reinforcement as per the requirement. And this PVC this PVC ball form comes with different coloring options. You can use white, off-white, or any other. So these are made in the factory as per your requirement, with opening or without openings, and then you just erect them on the foundation, and then put the reinforcement, use them as load-bearing or non-load-bearing applications. And so these are pre-finished walls. So just imagine you can buy the wall from the factory. This is a pre-finished wall which is made in the factory as per your project requirement. So it comes in in a certain width, and then you have a slide and lock kind of arrangement. So through that slide and lock arrangement, you can create the entire. And this technology is being used in Project at Lucknow. This was all about the 54 technologies which we have shortlisted, and I hope that you have got the feeling of what we are trying to promote, and what are the advantages and what are these technologies. So these are the 6 broad categories in which we have defined tried to define these 54 technologies. Let me also tell you that if in order to propagate, promote, or replicate these technologies, you need to create a suitable ecosystem. So a whole lot of activities are being done by Ministry of Housing and Urban Affairs through technology submission, and we are working along with various academic and R&D institutions, various state governments, so that these technologies are proliferated in various states. Okay, we are also working with BIS, Bureau of Indian Standard, and CPWD. All these 54 technology. The good news is Ministry of Housing and Urban Affairs, we have already approved these technologies for future construction. In fact, CPWD has also approved all these 54 technologies for uses in their building and construction projects. And under Pradhan Mantri Awas Yojana, also a major chunk of houses, around 1.6 million houses, are being constructed. We are also working with various state governments, and so that they can choose few of these technologies. And we don't say we have created a basket of technologies as per your requirement, suiting to your geoclimatic, natural hazard profile, as well as climatic condition. You can pick any of these technologies and make use of them, and the advantages of these technologies now. So with this, we come to the end of this lecture, and this is the last slide. Again, pictorially, I want to show you what we are trying to teach you, or what we are trying to promote in the construction sector. All of you know, construction sector is reticent in taking the innovations, and that is why we want to bring paradigm shift in the construction sector by bringing by taking a pole vault jump from level 0 to level 4. Normally the construction in our country or all over the world takes place in this style, where you collect the material, whether it is brick, cement, or shuttering, reinforcement at the site, and then everything is fabricated at the site, and then you do the construction. And what about taking a jump from here to level 2, level 3, or level 4, where instead of collecting the material painstakingly at the site, you get the things fabricated, manufactured at the factory and then just bring one fine day, you bring like we are doing in metro on bridges nowadays. So same thing can be done here. You make the walls in the factory, bring them to the site, and then just assemble them. And then start using them. So that's what we are trying to do, and hope one day we will have these systems. And another good news is that all these systems do exist in our country, and we showed you through these slides, there are a number of companies who are already into level 2, level 3, and level 4. All we have to do is repose faith in these technologies and start implementing them in our future projects. So with this, we come to the end of this the first lecture, where we gave you very quickly, I gave you the various technologies being shortlisted and being promoted through Global Housing Technology Chapter. So I will just move to the next lecture, which will be on specific technologies, and we will also show you through pictures the work being done there. Unfortunately, the project is over in Chennai, so we will not be able to take you to the casting yard and all. But if possible, through camera, we will have a virtual tour of the site. Okay, so I will just stop sharing, and I will move to next lecture. So the next lecture is on Chennai. Let me just share the screen. Okay. I hope you all are able to see. If somebody can help me out with yes, you are able to see the next screen.
Yes.
Yeah. So now let's move. 6 technologies. Remember what I showed you, that we have 54 new construction systems which are divided into 6 broad categories, and those 6 broad categories pictorially I try to explain you. Okay, now let's go to the specifics of Chennai project. So Chennai, the category which we are using is precast concrete construction, precast components assembled at site. So various structural components, whether it is beam, column, slab, or staircase, or sunshades, all of them are be cast in the casting yard, then transported to the construction site, and then assembled, jointed together, assembled, and then finished to create the entire building. Okay, so that is the category, and the technology being used is a branded technology of BG Shirke Private Limited, and they because it is branded, so they have their own name, but the broad category is precast concrete construction 2D. Okay, and you know the name of their technology is industrialized 3S, and I will explain you what is S. S means strength, safety, and speed. Okay, so industrialized 3S system using precast RCC columns, beams, precast solid slabs with AC block masonry. Okay. This already I showed you 54 technology, and so in Chennai we are using this category number 2, and there we had around 8 technology providers. So through a transparent bidding process, the project was awarded to BG Shirke using this technology. This is again a summary of the lighthouse projects. These are those 6 lighthouse projects. Today we are going to discuss this Chennai, where we are making in all these 6 projects 1,000+ houses are being constructed in various structural configuration. The buildings vary from G plus 6 story to as high as 14 story, and these again the dwelling units, because these are lighthouse projects are under Pradhan Mantri Awas Yojana, which is for EWS and LIG section. So all of these have a carpet area as defined by state government. So here the carpet area is around 26. So minimum carpet area is 25 or more, 25 square meter or more. So the carpet area is 26.58, and the total project cost is 116 dwelling units. This is the layout, just for your academic interest, and what you see on the right hand side. This is the layout. It comprises of 16 blocks. It comprises of 12 blocks and 12 blocks in G plus 5 configuration, and in totality we have 1152 houses. And in addition to these residential blocks, we do have social infrastructure comprising of Anganwadi, shops, library, ration shop, and a milk booth. This is a typical floor plan. So typical floor plan comprises, so at each floor we have around 16 dwelling unit, and I will show you the plan of a dwelling unit as well. So there are 16 dwelling units at each floor. We have 6 floors, and there are 12 blocks. In addition to that, we have social and physical infrastructure in this project. The total plot area, if you're interested, it is around 30,000 square meter, and the site is well connected with the city. Now, this is the typical dwelling unit plan. As you can see, it comprises of one hall, one bedroom, kitchen, WC, and bath. And under Pradhan Mantri Awas Yojana, we try to keep that there should be separate access from both the rooms to the bath and WC. So you can see here. So this is a typical layout, but the liberty of flexibility was given to the state government. So normally the state governments they propose the dwelling unit plan, but it has to comply with the space norms as given in National Building Code. So in all my lectures, I have been telling the participants that we do have National Building Code, and to civil engineers and architects, I also tell that that is the Bible for all of us. If you are planning something, if you need to refer to National Building Code. So for EWS and LIG category, they have space norms. Space norm means the code gives the minimum sizes of the room, minimum height, balcony width, staircase width, kitchen platform width. So all those things are given in National Building Code. So whatever dwelling unit plans are being proposed by state governments, they need to be they need to comply with National Building Code. Also, because these are lighthouse projects, or we call them these are pilot model projects. So here we have included various special features which can be emulated in the future projects if you want to have sustainable development, such as GRIHA rating. So at the very first instance, we have advised the agencies that during the project, or once the project is completed, you need to acquire minimum green rating of 3-star. So that is GRIHA rating. Then use of renewable resources. Whatever projects nowadays we do, we need to put in practice the sustainable practices. Sustainable practice in terms of rainwater harvesting, use of renewable resources, wastewater management. So all those things, special features, you will find in this project. And written here, we have solar lighting. And at common places, you can have solar lighting. Rainwater harvesting is also must. In all the lighthouse project, STP is must. Sewage treatment plant with wastewater management. Wastewater management means whatever waste water is being produced that need to be recycled and should be used for secondary purposes like gardening purposes or for flushing and all. And when you are going more than 15 meters, firefighting and firefighting norms are must. So as per National Building Code, all these buildings, all these lighthouse projects have fire rating compliance as well as have fire norms. Just to give you like a minimum width of staircase that is given in National Building Code, so that need to be complied with. Now, this already explained you what we are trying to do here. We are trying to replace this as visual approach on the systems which are in vogue or which are in practice is load bearing and auxiliary construction by this kind of construction. Okay. And this construction which you see on the right hand side, and we have written, so what we have for all these projects, we have conventional foundation. Okay, the reason is because soil conditions in our country vary from place to place. Go to the south, you may find rocky terrain. Go to hills, you find rocky terrain. Somewhere you may find marshy land or black cotton soil. Somewhere you have alluvial soil. So soil conditions vary from place to place. Water table also varies from place to place. In fact, in one of the project in Agartala, we have a marshy land. So there we have to use soil foundation. So at all these 6 sites, the foundation is conventional. And you can see here, so this is the foundation which is conventional, and all other things are being precast. Okay, whether we talk about this is a column. So column is precast column. So these are partially precast RCC hollow columns, and these are hollow columns where the core is filled in situ with self-compacting concrete. Similarly, we have beams which are also partially precast beam, and then these beams are connected with the columns, and then these are partially precast, and then they are cast along with slabs. So slabs are also cast. So all the 3 structural elements, beam, column, and slab, they are partially precast in the casting yard. And to have monolithic joint and to have wet jointing, these partially precast beam, column, and slabs are joined together some reinforcement is put, and then joined together through wet or cast in situ concrete, so as to have a monolithic joint, which I will explain you in the further slides. Also here, name any structural element, whether it is sunshade or whether it is a staircase, everything is being precast. And the infill walls are being filled with autoclaved aerated AAC blocks. Okay, so you all know that the building comprises of superstructure and substructure. Substructure is what we have below the ground level, which is typical foundation. So I will try to explain you the various structural elements through pictures. So we have foundation, then a structural system comprises of these beams, columns, slab, and then we have brick masonry and all, infill walls. So all these things, let me explain you one by one. So foundation, as I told you, it is conventional foundation. We are having a conventional foundation here. Conventional foundation may be of any type, depending upon the soil strata. It can be pile, it can be isolated footing, it can be combined footing, it can be raft. So here, because it's a typical precast beam column arrangement, so here isolated footing is being used. And again, as I told you, that it depends on the geotechnical or soil investigation report. So depending upon soil investigation report, you can design your foundation. Here the isolated footing and combined footings are used. Normally isolated footings are used, and if the spacing between the columns are less, then the isolated footing is converted into combined footing, where for one or two columns or more than two columns you have a combined footing. So here combined footing is being used as per the geotechnical investigations. Okay, then once you have the foundation, so after that foundation you need to have a column. So those columns are called stem columns, and these stem columns will come up to the plinth level. So plinth is at the ground level. So up to ground level you have these precast columns, and these columns come with a slit. This also I will explain you, and they come at the plinth level, and all these columns are connected with plinth beams at the plinth level. So this is your finished ground level. Okay, and as there are slits in the stem columns as well as in these beams. So these beams are perfectly fit here, and this hollowness, what you see here, and there you have the reinforcement cage, and these joints are filled cast in situ with self-compacting concrete, so that you have monolithic joint. So this kind of jointing is called emulative jointing, and this offers you monolithic structural integral joints. So the entire structure act together monolithically. Okay, so once you have a RCC footing, isolated footing, over that you have stem column up to plinth, and that plinth, all the columns are connected through plinth beam. And again, this is a good practice for earthquake resilience, because if you connect all the columns, the entire building at the plinth level, so in case of shaking, the entire building will act in unison or will vibrate together, thereby minimizing the damages and cracks and all. Okay. Anyway, I will explain you with the pictures, which I will show you. Then, so this was about the foundation or substructure. Then about the structural system, as I told you, that all beams, columns, slabs, sunshades, staircases, all of them are being cast in the casting yard for the project of Chennai. Casting yard is just at a nearby place. It was around half or 2 kilometers away from the site, where all these structural elements. And again, structural elements as per your project site. So what the sizes of columns, beams, and all, there will be molds, and you will cast those elements, and then you will transport them to the site and then erect them to give the shape of your building. Okay, and it is called, as I told you, this is a patented system of BG and the name is industrialized 3S. 3S stands for strength, safety, speed, and now they have added another word, sustainability. So it's a prefab method of construction, where precast structural components are cast in the casting yard or in the factory. When you cast the component in the factory, so it is also called off-site construction. So remember, one is on-site construction, where you do everything at the site, and if you take the construction off-site, means in the factory, then it is called off-site construction also. And the uniqueness of the technology of BG is all these columns, beams, slabs are partially precast. And why they are partially precast? Because the remaining portion is cast at the site, so as to join various structural elements together and to make them monolithic structures. So once you have frame frame erected with slabs and all the walls, these are called infill spaces. So these infill spaces are being filled here with AAC blocks. And as I showed you, you can fill it with any other. There are a whole lot of options. You can have, other kind of drywall construction, sandwich panel system, which can be used to have this infill wall. But for this project, this AAC block is being used. AAC block is also excellent as far as thermal comfort is being concerned. I think I have a slide where I will show you what does that AAC stands for, aerated autoclave concrete blocks. Okay. These are lightweight concrete blocks. Then slab is again, it is again partially precast, and what you see in this picture is that slab. So slab is cast in it is partially precast. So half of the slab is cast in the factory, then it is being put on the already erected RCC beam and column. And once you erect this with bearing and all, then you cast, then you put little bit of reinforcement, nominal reinforcement, and cast this slab together with beam and column. So once you cast this beam, column, and slab together partially, then you can achieve monolithic jointing. And that is why these kind of jointing are called emulative jointing. So that's what is written here. The partially precast slab, precast beam, and columns are assembled together at the site. Assembled and wet jointed through a screed of reinforced concrete, making it monolithic structure. Okay, then AAC block, all these walls are infill blocks, and these are autoclaved aerated blocks, which are very lightweight, and the sizes are also much higher than your brick. These are typically 600 to 200 by 150 mm, and they are also manufactured and being lightweight, they can be easily erected, and they enhance the thermal comfort of your building drastically. Okay. And advantages, I don't need to go into the details of these advantages. Whatever advantages, merits, I explained to you in the previous lecture. All these advantages are there in this technology as well. You might be wondering what are the limitations. The limitation is, first of all, because all these precast concrete construction require a factory setup, or you need to set up a casting yard. So you require a critical mass. Critical mass means economies of scale, or minimum built up area, or minimum number of houses are required to bring the viability or to bring the feasibility of the project. So that is one limitation. Minimum number of dwelling units are required to achieve cost economy, and but that can also be overcome if you have demand. I can give you the example of Delhi. In Delhi, around 80,000 houses are being built with this precast concrete construction system. So if you have demand, the cost will automatically come down. And secondly, because whole set of new erection methodology, assembly methodology, transporting methodology, lifting of these precast components require skilled manpower. So you require skilled manpower. But again, the good news is the already existing manpower can be trained to work on these projects, and that is why most of the agencies do. At the site itself, on-site training is imparted to the people so that they can be trained to work on these new technologies. Okay, and again, there are two methodologies for as far as procurement is being concerned. One is item rate tenders, and one is design build approach. In design build approach, you have a plot area, and you ask the agency to design it and quote the rate, per dwelling unit or per meter square. So design is theirs, and they need to build. So this is design build approach. This is and this approach was used very beneficially in highways, and now it is being used in building construction as well. So the project was awarded to BG Shirke, and in this project, in most of the projects which we are doing, lighthouse projects, there is one technology provider and one is the construction agency. Okay, and here the technology is also of BG Shirke, and they are the agency who are constructing this project. Okay. Then design philosophy and all, when you are doing with RCC frame construction, you are doing, so there are the two codes are very important. One is IS 456, which is the reinforced concrete code, and another is another is a steel code. Then you have ductility code, because if you are doing in India, we have 4 seismic zones, and to have better disaster resilience, and now and then it is being talked that joints and all are not good in case of precast concrete construction. Let me tell you that all these joints are specifically designed, specially designed, detailed as per the laid principles in various Indian standards. So strictly complying to those Indian standards, which will bring ductility, disaster resilience, the design is being done using those codes. So there is absolutely no problem as far as performance of these precast components and joints are concerned. And for meeting the durability service requirement, there are a whole lot of codes. 4x6 also gives you, minimum content of cement required, maximum water cement ratio, type of reinforcement detailing. So what I want to say here is that the technical framework is all the Indian standards which are applicable for this kind of construction. Okay, so when we do a design basis, so you need to prepare a design basis report, which is also very important. Okay, whenever design build project is being done, design basis report forms the part of your detailed project report, and that design basis report need to be vetted by third party. Okay, and this came into force after the Gujarat earthquake, that instead of just approving the drawings, you need to ensure the design basis and design is being done as per the laid down principles. So this is, I will not go into the details. So design basis means, depending upon the soil investigation, safe bearing capacity is calculated, and the depth of foundation based on soil strata is found out, and then you design the foundation. So here foundation is isolated footing having depth 2.5 to 3.5 meters. Then in order to design a structure frame which comprises of beam, column and slab, you need to ascertain different loads. So the wind load, earthquake load, and there are standards available. This is a wind hazard zone map of our country, and Chennai being a coastal region, it falls in a high damage risk zone as far as wind speed is concerned. Wind speed is around 50 meters per second. So this wind speed is converted into pressure and then later converted into lateral force, which is applied at each story to design your building. Okay, and the entire building, because it has emulative joints, wet jointing, so the entire building is treated as moment resting frame with the shear walling system. So this was about the wind. Then this is the map of earthquake zoning map of our country, and fortunately Chennai falls in seismic zone 3, which is a moderate damage risk zone. But the moment you bring in the seismic zoning map, you have to refer IS 1893. You have to find out the seismic coefficient, then find out the lateral shear. That lateral shear need to be distributed at all these stories depending upon the stiffness of each story, and then you have to carry out the analysis and design, and then ductility code, and there are other whole lot of codes which need to be referred to have design and detailing requirements. Also, because we are using AAC blocks here, so you can see the last thermal comfort levels are also being ensured. So there is a code, Indian Standard IS 3792, which gives you thermal comfort for depending upon the users of your building. So AAC block will ensure the thermal transfer level below 2.56 watts per meter per Kelvin. So this is just for academic purposes, the calculation, seismic load calculation. And once you have done these calculations, the computer model of the building is generated. Analytical model it is called, and it is subjected to 13 load combinations. Okay, so it's a very involved exercise when you do the design. So structural analysis is done for 13 load combinations, various combinations of dead load, live load, earthquake load, and wind load, and with various load factors. And for the worst possible load combination, your building is being designed. And design means the size and shapes of your various structural elements, the reinforcement being used, the percentage of reinforcement. All these things come from analysis and design. And again, there are a whole lot of softwares nowadays available through which you can very quickly create the model of your building, and then you can design the building. Also, these buildings are designed for limited state of collapse and serviceability. That means during the service life of the building will never collapse. And in case of extreme events, the building will remain serviceable. Okay, so that is also there. And because we are using new technologies here, all these design basis report and design and analysis report are to be vetted by third party. In Chennai case, the entire design philosophy, everything was vetted by IIT Bombay. Now, whenever you are dealing with precast concrete components, you have to use high grade of concrete, normally M30, M40. I think I showed you this, that we are using M35 for foundation, and for beam and column, we are using M40. So below the ground, we are using M35, and above the ground for structural elements, M40 is being used. So M40 is pretty high grade of concrete. And when you use high grade of concrete nowadays, instead of having nominal mix, you use the, you don't use use the nominal mix, but instead you use the design mix. And so design mix was done by IIT Madras. And you can see here why I have given you this slide, that you can see instead of using 100% cement, the up to 15%, 15.73% cement is being replaced by GGBS, which is granulated blast furnace slag. Okay, it is ground granulated blast furnace slag. And if you remember this slag is the byproduct of steel industry. So you are using this waste up to 15% of precious cement resource is being replaced by this byproduct, which was otherwise a waste in preparing this mix proportion or concrete mix, and thereby making your concrete clean, sustainable, resource efficiency. And here the persons who are from Tamil Nadu, they all know that you don't get a river sand here. So here we are using manufactured sand. So manufactured sand is being used in this mix design. So this mix design is again being done, and when you do the mix design, you are optimally, very accurately, you are calculating the mix proportions and the weight of different raw materials, whether it's fine aggregate, coarse aggregate, the amount of water, the maximum cement content, and actually mix them and achieve the target strength very accurately. So normally when you do a big project, you have to install a batching plant at the site. So here also a batching plant was established at the site. And what you see, these are the silos where the material is being stored, and then through these silos, through automatic controls, accurately weigh the quantities of material and then prepare that concrete. Because when you are using precast concrete, these are thin elements, so accuracy is the importance, and quality is also of prime importance. So you cannot compromise with the quality of concrete being used in the project. Okay, now let me show you, because we will not be able to take you to because the casting yard, the project is over. So this is the typical pictures of a casting yard. And if you are really interested in visiting the casting yards, you can go. There are a few casting yards operational in Delhi. So in Delhi, you can see the casting yard. Typical casting yard comprises of, big beds, casting beds where you have mold. So what you see, this blue thing is the mold. So mold is nothing but a steel mold which will give the desired shape to your beam and columns, and then you put up, and it is an assembly line production kind of thing. So each person has been assigned a specific duty. So oiling the mold, then putting the reinforcement, putting the winding wire, then the next person comes and the concrete is being poured, then demolding is being done. So this is a typical casting yard and here the beams are being cast, you can see. And this is a typical casting bed for slabs. So that was for beam. What you see in blue. Okay. Oops. Yeah, so this was for beam, this is for slab. So you have a big casting yard where all these slabs are being cast together, and to have accelerated curing, these curing is done under high temperature and pressure. So they can be very very fast. They can be cured and can be used. And in precast, curing is normally expedited by putting some admixtures. Okay, so that there is early gain of strength, so that they can be lifted, cured fast, and they can be taken to the site. And again, these are partially precast slabs. So you can see, so once you cast these, then you have to, store them. You have to stack them properly and do the curing for 14 days, depending upon the requirements. So you can see all these are pictures from the casting yard. So this is how it is being tilted. So these are, rotating tables. These are called rotating tables for slabs. And this is being tilted, and this is the slab being lifted. This is for beam and columns, you can see, and this is for staircase. So all these things are being cast at the casting yard. Now let me also show you the construction system sequence pretty quickly through pictures only. Foundation and structural system. This is a typical picture, structural line, which need to be referred. And what you see here, the smaller rectangles give you the positions of column, and the bigger rectangles give you the foundation layout or the isolated footing. And where we have combined footing, so there you have a big rectangle and small rectangles unit the isolated footing. And this is a typical setup you can see. So normally you have a PCC. Plain cement concrete of 100 mm, and over there this is a typical structural drawing of your foundation. So what you have here, you have a foundation, then you have a stem column up to plinth, and at plinth level you connect all the stem columns with the plinth beam, and then you start erecting beam, column, and slab. Okay, I don't want to make it more complicated, so I will show you immediately the drawings, but I just wanted to give you one more thing here. One more thing I want to teach you here, that strictly when you are using RCC beam column kind of thing, so there is a code called 13920. That's a ductile detailing code. That code is a Bible for ductile detailing, and ductile detailing means what should be the lap length, how much length of steel from the beam should go into the column, what should be the spacing at the joint. All these things are given in the in that 13920, and that need to be strictly complied. Okay, and these stem columns, because Chennai is a coastal region, so the chloride content of soil, subsoil, chloride contents in the subsoil are quite high. So all these exposed concrete surfaces are, exposed concrete surfaces are being painted with bitumen paint, and all the reinforcement below the substructure has to have invariably anti-corrosive coating. So all the reinforcement which we have, because it's a coastal region and high chloride content, they are painted with anti-corrosive coating. So these are the pictures. You can see typically, depending upon the depth of your foundation, the depth is 2.5 to 3.5 meters. What you do, you excavate as per your layout. And then here another thing was, because the site is near to the coast, near to the sea, so constantly there was the ingress of water. So continuously the water is being drained, and then the ingress of water to the site is being prevented through bentonite and all kind of things. Constant pumping of water and then laying the foundation. Okay. So you can see this is the typical. So these are the, because the ground to make plain surface, first of all, before laying foundation, you have to lay the PCC, which is plain cement concrete, which is of 100 mm thickness. So that over that PCC, you have to lay the reinforcement. Okay. So that is PCC. Over that PCC, you lay the reinforcement of isolated footing, and then over that isolated footing, then you cast the isolated footing partially with this, and then you have this reinforcement of stem column. Then you put the already precast stem column up to the plinth, and then you will have plinth frame. I will show you the pictures. Yeah. So this is the close-up of this reinforcement. Again, this reinforcement, their spacing, their lap length, the U kind of thing, and how much it is to be bent, and all everything comes from the code 13920 and other codes. And then once you have this kind of, this is called reinforcement cage, you lay this reinforcement cage. This is the closure loop. You pour the concrete, and once you pour the concrete, you get this kind of isolated footings. And what you see here, over that isolated footing, you have to put that, you see here. So these are those isolated footing being cast, and then you have to do the curing. Constant curing is being done. So you can do it can be done either ways. You can sprinkle the water, you can do the ponding, you can immerse the entire footing or slab with the water, or you can put a Haitian cloth or dori, and you can keep on wetting it so that the heat loss is minimized and concrete gains its full strength. Okay, so this is various pictures you can see. So this is that Haitian cloth I'm talking about, and this is a closure look of casting of those isolated footing and all you can see. This is another view, and what you see here, these are the columns, and all these are the positions of those stem columns, which will, why we are calling them stem columns. So stem column connects your superstructure with the substructure. So column connecting the superstructure with your foundation is called stem column. Okay, so these stem columns are again precast, and they will be inserted here, and then our reinforcement cage will be lowered, and then they will be cast with the plinth beam. Okay, so these are those stem column I was talking about, and as I was telling you, below subsoil, you are painting them with bitumen paint because chloride contents are quite high here, and also the OPC cement used was of grade 53 with C3A content, which was needed for because it's an extreme aggressive environment being coastal region, and this is the kind of thing being done. And now what you see here, these are the slits. So over these slits, plinth beam will rest. That we have. So these are those stem columns, and these stem columns are of different heights, 2 meters, 2.5 meter, and they will terminate at the plinth level. You can see. So again, a closure look, and what you see here, this is that slit I am talking about. Again, this is another view. Let me show you this. Yeah. So now once you have come to the ground level or the plinth level, you have already precast plinth beam. So on those slits, those precast beam will come. So what you have here, you have a column and you have a cavity here, which will have reinforcement of column and some reinforcement of beam will go here. And these joints will be cast in situ through wet jointing, through self-compacting concrete. These joints are being cast so that you have a monolithic joint here. Okay, so this is at the plinth level. You can see. So this is what you see. These are already, you know, this kind of jointing. So this will perfectly snugly placed here. You have a fit joint, and then you will do the wet jointing by loading the cage with self-compacting compacting concrete and then micro concrete and non-sheet ground. This is a closure loop. You can see that plinth beams are being erected. There, this is being in progress. You can see. So once you have done that, then you have to do the backfilling, and over this, your columns will, precast columns will come. And now nothing is visible here. Once you have filled the entire, excavated soil through backfilling, so you get this plinth level. And so this is how it looks like once the substructure work is over. So all you have, so these are those SAM columns with plinth beam at the plinth level, and then you will have the columns there. So let's come to the column, and column are again, these are hollow core precast columns. So these are hollow core. So they are just precasting the core of the column, and then the reinforcement cage will be lowered, and then the joints are being cast in situ with wet jointing. Okay, so typical the concrete grade uses M40. Let me show you. And just to keep the, column, already these columns are cast with this reinforcement. And then again, an additional mesh is being provided here to have the dimensional accuracy. Okay, so this additional mesh is being provided here. And then a special kind of slit or sleeve is put during the casting so that these columns can be lifted at the side. So through this hook and this steel rod, these columns are being lifted and then being fitted into this like this, you can see. So these, you have that steam termination of steam column at the stem column at the plinth level, and these columns with this detail which I showed you, with this detail they are being erected here like this. Okay, and then over the slit the beam will come, and then you will join them together. Okay, and here also it will be wet jointed. Now you can see now the placement of ground floor beams on columns. So this is how the beams are being put, and now you can see this. So once you are putting this is a typical beam column slab joint. So you have that, then over that you will put the slab, and these joints are filled at the side, and monolithic jointing is being accomplished through self-compacting concrete, because these joints are heavily reinforced. So you can't have a concrete of usual thing. So you need to have a you cannot use vibrators and all. So you have to have a flowable concrete. So you use a special concrete, self-compacting concrete, and micro concrete and non-sheet ground to create a monolithic joint. So I think you now understand. You come to any level, and the joints between beam, column, slab, they are filled with special self-compacting concrete or non-sheet ground to create a monolithic joint at the site. Okay, so this is how it looks like. You can see here. So this is before jointing. So these are the joints which are opening up, and then you fill them, to achieve monolithic action and continuity. Okay, so these are different drawings, and what you see, these are partially precast, and what you see in these drawings, this is the portion. So 300 mm, beam is cast in the casting yard, and the 130 mm is cast together with the slab and column to have monolithic joint, and additional reinforcement is being put so as to achieve the monolithic joint. Okay. So I just don't want to go. So for everything, whether it is staircase, beam, column, beam, slab, everything is done like this. Now you can see in this picture here, the slab is being lowered. So on the already precast beam and column framework, you are just lowering the partially precast slab. And this slab has lattice girder. I will show you in the next picture. Then you put some additional reinforcement and then cast this. And then over the slab, you will put the screed concrete. That is screed concrete together with beam column joint will be cast together to have a monolithic joint. So this is a typical detail. You can see these are the lattice girders, which is a triangular reinforcement, and in that the bar will go, and then the screeding will go. Okay, I will show you. Yeah. You can see here. So this is once the your partially precast slabs are laid over the already laid beam and columns. Then you have a lattice. Then you lay the nominal reinforcement here, and then finally screed concrete up to 50 mm or 55 mm thickness is poured over the partially precast slab to ensure monolithic continuous action. So this beam column joined with slab, and these slabs are laid on a sufficient bearing with beam, and then you achieve the monolithicity. So it's a perfect monolithic continuous action, ensuring ductile behavior of the structure during earthquakes. And once it is over, then you need to cure it. So curing is also very important, and it's one of the good practice. If you don't do curing and all, the desired strength will not be achieved. So basically, as I've been repeatedly telling you, that all these are hollow cores of beam and columns, and to achieve continuity and monolithic behaviors, these are first placed at the site, and then connection joints are filled with in situ self-compacting concrete. Let me show you the now different views of these. The project is already finished, and now it's very, I think some infrastructure work, little bit of infrastructure work of laying the roads is remaining. The structural part, finishing part is over. So let me just show you. So you can see here these precast slabs. This is a closure look. You can see now that once that is ready, you will pour the screed concrete. And now this is, this is the first floor, this is the second floor column. So like this, you will do, story by story. Once this story is over, then you can, have AC block masonry over here. So this is the second floor. Then this is that infill, whatever spaces are between the beam column, they are filled with AC. They are special kind of blocks, autoclaved aerated concrete, which comprises of sand, gypsum, lime, cement, water, and aluminium powder. And there is no aggregate, so they are very light in weight. And imagine the density is only 500 kg per meter cube. Whereas for brick, I don't know whether you know, it is 1800 kg per meter cube. So it's 3.5 times lighter than your AC. Then your brick and concrete density is 2500 kg per meter. So they are much lighter in weight, and their size as compared to brick size, which is 230 by 150 by 75 mm, they are bigger in sizes. And two kinds of blocks are being used. For outer walls, they have greater depth or greater thickness, where internal walls have less 100 mm thick, so they can be pretty fast. These walls can be laid, and this comprises of even fly ash is being used in this. So these are, and they provide excellent thermal comfort. So this is how it looks like. You can see various pictures here. So as I told you, this is G+5. So in all you have 6 stories, and this is. Now, once this is over, then you have to do the external plastering. So this picture shows you the external plastering work in progress. Another picture with external plastering. This is the overall bird's eye view of the entire project. There are 12 blocks comprising of 1152 dwelling units. Yeah, so another view you can see, and you have, whenever you are doing this kind of precast concreting work, tower crane is must, because you have to have tower cranes installed at various strategic locations through which you can, lift the material and erect them at the site. And if time, permits, I will show you a few videos where the erection of column and slab is being done. So these are those tower cranes which you see here. And once you do the external plastering, then you have to do the painting. So here, painting is being done, you can see. So these are finished houses, and now you can make out the technology being used here. Okay, and this is also a slide which we are showing in all the webinars, that the advantage with these all technologies that you need to have a quality control and quality assurance lab at the site. So all these components at the casting yard and at the site are again tested for their quality control and assurance. So you have typically compression testing machine, a sieve analysis for the material being used, so that you can assure the desired quality. A lot of questions are being asked for services and plumbing in precast concrete construction again here, because you're erecting columns, beams, and everything at the site. So those plumbing and electrical services, MEP, they are done as being done in the conventional system through chiseling and chasing and fire. Okay, and in this project, boundary wall is also being done with precast. Nowadays, for boundary wall also precast concrete construction technology is available. So here they have, these precast concrete panels along with pedestals, and this is the boundary wall in progress. This is again precast cabinet being used in the project. This is that toilet in the project. This is that internal AC block, and then this will be plastered. Okay. This is the kitchen cabinet. This is how the typical door frame is being faced. Why I'm showing you these slides, that this technology is amenable or compatible with the usual conventional construction. So all those things which you do in a typical conventional RCC construction, all those techniques can be employed here for MEP services. Okay. So electrical work, as you can, is the MCB junction box is being put like you do in conventional construction. Then putty and primer work being done, floor tile work being done here. The project, as I told you, is already completed. This is how the tiles are being fixed here. Then this is the corridor painting. This is plumbing work for the kitchen. Sanitary fitting. This is your electrical room connections, you can see, and this is the overall site view. Okay, and this is also now this, as I told you, that road work is finishing. Road work is being finished right now. So this is that current project view. Okay, another view for you. And so that is all about this project. So I think I am able to explain you all these technologies, the specifics of technologies, and the finishing items, as you can see, because earlier also I told you these are model projects, so we have used high-end, we have given high-end specification for finishing. All the, we are using pressed steel door frames with flush shutters for windows and frames, and for wet areas, PVC doors are being used, and UPVC frame with glazed panels for windows, vitrified tiles for floors, for rooms and kitchens, for wet areas, anti-skid ceramic tiles, and for common areas, quota stone. And as far as infrastructure is concerned, all good practices, green practices are being included in the project, like firefighting system and renewable energy resources, solar lighting, LED lights, sewage treatment plant, wastewater treatment, rainwater harvesting. Horticulture is also must. Sometimes it is found that once the project is over, you will not find any greenness. So all this project must have trees planted there. So horticulture is also being included along with solid waste management. So this is all about the Chennai project. And as I told you in the beginning, that in order to see the live status, and if you want to get connected with these projects in real time, you just visit this website. You can make a note of this website, gstc-india.gov.in. Then in the pull down menu, you will find a tab with bearing the name LHP. If you press that LHP, you will be taken, there will be one tab on live status. So go to that live status and you can see yourself the progress and the various stages of the construction. Okay, so with this, I end this lecture, and in case you have any doubts, any queries, you can always write to us on ministry's email, which is written in the bottom rightmost corner, or otherwise you can also write to me, and we will try to address your issues or your problem. Okay, so this that is all from my side, and if Manish, if you are there, we can take them to the site, or if you want, I can show them a few videos.
Sir, thank you very much. I think we have some technical issues at the LHP site, but we have kind of managed to show the participants the live view of the site. Can I request Dhanshekar to share the screen and show the live feeding, please? We have tried to show the project site from the top terrace of one of the building, so that the entire view can be seen. This is most likely, yeah. So, Dhanshekar, you have to share your screen and start explaining. Right. So you have to keep your camera in the right position so that we can view the entire project in one go. Yeah, Dhansekhar, can you please connect? Right. I think थोड़ा उसको सीधा कर लीजिए धनशेखर, आप कैमरा सीधा कर लीजिए, उल्टा हो रहा है. So what we have done is we have tried to manage a portable camera, and we are trying to connect that camera with this webinar. Dhanshekar, are you connected? Right.
Sir, is that video clear, sir?
Yes, it's clear now. Right.
Share, you have to share your screen.
It's visible, sir. It's visible now.
Okay.
Dhanshekar, you have to start talking also what exactly you are showing, how many blocks, how many floors,
Total
and
this
what exactly is happening right now.
12 blocks, sir. All the blocks work have been completed. Now only infra work is in progress, sir. So like roadworks and landscaping work are in progress. So all the buildings have been completed, sir.
So all 12 buildings are completed.
Yes, sir. Yes, sir. And this
what are these
buildings are library, milk booth, amenity buildings, sir. Anganwadis and shops.
So one is
These are-
library, milk booth, Anganwadi, shops, and community
and
center.
sir.
Okay, and we can very well see the road. That's the final road now, the main
Yes, sir. Sir.
connecting
Laying,
road.
sir.
And what are the works which are currently going on?
Only landscaping work is in progress, sir. Other than that,
Landscaping.
testing and commissioning work is in progress, sir.
What about drinking water, STP, sewerage?
STP, everything has been, installation has been completed, sir.
Right.
Yes, sir. Water connection from the municipality, we are waiting for the connection, sir. Our internal works has been completed, sir. Even sewer line and everything has been completed. What you are seeing is this UG tank, sir.
Okay. So basically, you are good to go. You are ready to allot these houses to the beneficiaries. I hope the beneficiaries have been identified.
Sir, already identified, sir.
And do we have the entire project fenced? Walling, fencing has been done?
Yes, sir. Compound, sir.
Great. Can you show the terrace? We understand that there is a system of solar panel also installed. So you have a water tank on the terrace.
Yes, sir. This is lift machine room, sir.
We lost your video, I think.
Now it is connected, sir.
Yeah. So great.
Video is getting cut, not continuous. It is
Not a problem. We kind of saw the overall project.
yes.
It's exactly like the way Shailesh sir was showing in the picture. It's exactly the same. Okay. Right. Thank you, Dhanshekar. Thank you. All the connections of water and everything has been done, no?
Yes, sir. Yes, sir. Everything is ready for occupation, sir.
Okay. And as Shailesh sir was saying that after completion of the project, it would be very difficult to identify the technology being used in that project. So it's exactly the same. So thank you, Dhanshekar. Thank you very much. Shailesh sir, you want to add?
Okay, I think because as I told you earlier also, because the project is already finished, so we are not able to show you, we are not able to take you to the casting yard, but I think I have showed you the entire philosophy as well as through pictures, how these things are being done at the site. Manish, if there is time, I can show one or two videos if you want. Otherwise, it's okay. I think most of them have understood. If there are some questions, I can answer them. There is one question only I can find. That's a good question. What is the cycle time for each floor construction? I just talked to the agency. It's 10 days. In 10 days, they are finishing one floor in this particular Chennai project. So this is the only question available, Manish. There are no other.
I think we have around 120 participants. If somebody wants to ask live question, we can take those. Otherwise, we can wind up.
Hello.
So if anyone, yeah.
Hello, this is Manoj Kumar Sinha from Visakhapatnam.
Okay.
Yeah.
My question is, for the conventional type construction, you told that one of the slide you showed that they are unhealthy indoor qualities.
Yes.
How it is unhealthy? Because
okay. Yeah, that's a good question. Let me answer you. Yeah, for everybody's, it will come to the surprise to all of you that there have been several studies. Okay, and through those several studies, it has been found that indoor air quality is 2 to 3 times more detrimental to health than the outside air quality. Let me repeat again. Then I will tell you why. And that is why, green systems, green, buildings are being talked about. Inside air quality is 2 to 3 times more detrimental or more vitiated than the outside air quality. And why it is happening? Because the kind of paints, varnishes, pesticides, treatments being used in the buildings. Okay, the kind of air conditioning and things being used. That is why nowadays, when we talk about green buildings, we are talking about VOC. VOC is volatile organic compound. So when you are inside the building, okay, so constantly, very fine particles are being emitted. Organic compounds are being emitted. Like I'm talking right now, so I'm emitting volatile organic compounds. And all the materials which are here, whether it is paneling, the adhesives, kind of adhesives we are using, they all are emitting volatile organic compound, making the air quality, indoor air quality, dangerous. And the point which I wanted to make, that when we do a conventional construction, we always take indoor air quality for granted. So that also need to be seen. In fact, if you are more interested, we have certified a technology as sandwich panel system, which is having MGO board as a skin. And if you know MGO, what it does, it reacts with the carbon dioxide of the environment, thereby creating the healthy environment. So now, if you refer any green rating code, they all have this indoor air quality as one of the indicator, and thereby stressing the point that let's use materials which have low VOC. Okay, so that is why when we talk about green buildings, talk about this indoor air quality as well. Okay, thank you,
Manoj.
Acha, okay.
Sir, we have another question in the chat box.
That casting yard, I think it was around 3 kilometers. Pankaj, are you there? Pankaj, fere saath hai kya, Manish? I think it is 3 kilometers because, it depends. Like in Delhi, 80,000 houses are being constructed with the same Shirke technologies. So they have a, casting yard at, 2 or 3 places which are 10 to 15 kilometers away from the casting yard. I will just ask Pankaj.
Right.
It should not be economical if it is more than 10 kilometers.
Anybody else? Do we have more questions?
Okay, Manish, I just checked from Pankaj, it is half a kilometer. And Rakesh, I think your question is well understood. In fact, the day before yesterday, somebody asked me if I want to use precast, what is the economical distance? So it's around, if you have a casting yard or a factory within 100 to 300 kilometers, the technology becomes viable. Okay. Next question is, what is the cost of construction? It's 10%. See, again, it depends on economies of scale. a critical mass or minimum number of dwelling units of built up area. For this, this is one of the cheapest one of the most cost effective projects out of all the 6 LHPs which we are doing with precast. So here it is around 10 to 15% less than your conventional construction. Okay. Next question: difference between MY1 and this technology. I think you should make it out yourself. I have already told you. In MY1, it's a formwork system where all the walls are cast together, cast in situ. Here you are casting partial structural elements are cast in the factory and then brought to the site. In MY1, entire thing is being cast at the site itself. So that is the difference. Any other question?
I think we are almost done. It's been 2 hours. If we have any further question, then we'll take it. Otherwise, we can have a group photo and then we can close the meeting, sir.
But first of all, let me also, invite Vikas, a dear friend of mine, to propose vote of thanks.
Yeah.
And Manish, you also deserve a special applaud because you have conducted this session very well. And now I, invite Vishal to propose vote of thanks. And after that, as Manish was telling, all of you may switch on your videos so that we can take a group photograph. Over to you, Vikas. Vikas.
Thank you, sir. Thank you very much, sir. Good evening to you all. Namaste. It is my privilege and great pleasure to thank you, all the participants here today, for the 5th webinar and live feed demonstrations of Chennai LHP being organized by MOHUA, BMTPC, and GIZ. You are all the real ambassadors of these projects because you have to go to the site and tell everybody that what is going on in terms of technologies and all. So GIZ and I will tell you about something about GIZ as well. GIZ and Cable are the 2 arms of German international cooperation set up by German government. We are dealing with technical support and KW deals with the financial supports internationally. We are having our presence in more than 120 countries with more than 25,000 employees. In India, we have been working here from last 65 years and strongly moving towards achieving 17 SDGs. With more than 60 million euros spending per year on technical support, we strive to achieve our objectives through ground implementations. So previously, we have worked with MOP and developed several policy elements like Econiva Samhita Code, building rating systems, applicable designs for urban residential housings, and building material directory. All these exercises are quite relevant to our present endeavor with MOHUA. So this is what about GIZ, and I must thank and to Mr. Kuldeep Narayan, Joint Secretary and Mission Director for Housing for All, with who has delivered and addressed us in the previous session. I extend my heartfelt thanks to him for being present here and given his this event a valuable attention. Despite his busy schedule, he always tries to join these webinars to interact with the participants and encourage them to have further learnings through these live laboratories. I would also like to thank Sri R.K. Gautam, Director of MOHUA, for his constant efforts to bring this LHP technology to the newer heights. My special thanks goes to Sri Sailesh Kumar Agarwal, AD BMPTPC, and his team to bring this innovative technology for the first time in India, an idea of having live laboratories for in-field learnings to students, engineers, architects, developers, and professionals. So, I sincerely thank Mr. Manish Kumar, Regional Coordinator MOHUA, and his team for bringing this naive idea of conducting these live feed and technical webinars on LHPs. This will be continued in future on rotation basis. So participants, you will see many more construction developments happening within a span of 1 month. And finally, I would like to thank the Lhp Chennai site project partners, technology provider Mr. Vijay Shirke, and GIZ's CSB team for providing the site input to the participants. Thank you all. Thanks a lot. Over to you, sir.
Thank you, Vikas. And Manish, if we can request everyone, all of you may switch on your videos so that we can take a group photograph, virtual group photograph it is called. So all of you are requested to switch on your video. You can take now, Manish. You can take the photograph.
Sir, we'll take. I'll take.
I'm getting a very beautiful view of Kanha, Sunil, and you along with me above you on a television. That's a good view.
Can everyone switch on their camera, video? Nice, nice. Sir, in the meantime, you may want to just inform everyone that anybody can go and visit the LHP sites.
I think, Manish, you can correct me. We have identified 10th, 20th, and 30th of every month.
Right, sir.
10th,
all 6 LHPs are open.
All 6 LHPs, all of you can go and visit on these specific 10th, 20th, and 30th. Okay. And there will be technical personals available there, which can explain you technology. So these 3 dates are earmarked especially. In case you are not able to make it on 10th, 20th, or 30th, you can go and visit any other day as well. There is absolutely no problem. And you can see yourself, ask questions there. We have technical people, we have a BMTPC engineer, we have agency, technology provider, GIZ team. You can have discussion with them and acquire the knowledge. And again, repeatedly, I've been telling you, it's a unique opportunity where for the first time, proactively, Government of India is showcasing these innovative construction systems for the betterment of our country. So all of you must, as engineering and architectural fraternity, professional fraternity, we must make use of this unique opportunity and visit these sites. And you all know, seeing is believing. In civil engineering, unless we go and see with our own eyes, we won't be able to understand the efficacy, the advantages, merits, demerits, limitations of these technologies. So we strongly advise all of you, whenever you get time, you go and visit these lighthouse projects. Okay. And also, if you are not registered as Technograhis, all you have to do is you have to visit the GST sheet, that's india.gov.in website, and just put your name along with your Aadhaar card and photograph. You will be registered as Technograhis. The advantage is you will start getting the regular communication from ministry, and that we will be connected with ministry. Also, in case you want to take a deep dive into these technologies, a lot of literature is uploaded on ministry's website, on BMTPC website. And in fact, I have been telling this, we have started a YouTube channel and we are getting very encouraging results. So all these, films, audiovisual capsules, training modules, all those are available on our YouTube channel as well. So just type BMTPC, you will get access to our YouTube channel and download all this material. So with this, thank you everyone, and we will be holding next webinar in Agartala, and then we'll be repeating all these webinars. So with this, if Manish, you have taken
Yes, sir. Thank you very much. We've taken a picture. We'll post it. All the presentation and videos are available on the website, so anybody can download and view those slides that were presented today. So thank you very much. Thank you, everyone.
Okay.
We'll close this webinar. Thank you.